Welcome to part 9 in the series of videos on the drying of fruits and vegetables. In this presentation, we will examine the drying of tomatoes. My name is Don Mercer, and I am with the Department of Food Science at the Ontario Agricultural College, University of Guelph. We will begin with several acknowledgements and a brief disclaimer. Then we will move on to a short introduction, which we will follow with an explanation of how sun-dried tomatoes are manufactured. We'll look at the drying mechanism for tomatoes and how the material is prepared for drying. Once this has been completed, we'll examine the temperatures required for drying tomatoes, as well as the air velocity and conducting the actual drying runs. Then we'll move on to testing for doneness and complete the presentation with some summary comments. I would like to thank Mr. Andrew Goodwin, Associate Industrial Development Expert with the Agribusiness Development Branch of the United Nations Industrial Development Organization, for his considerable efforts in coordinating this project. I would also like to thank those who are assisting in the presentation of this material to various local groups. Their contributions to our training activities are greatly appreciated. The author assumes no responsibility or liability for any problems of any nature encountered through the application of the principles discussed here. This material is intended for instructional purposes only. The purpose of this presentation is to outline procedures relating to the drying of tomatoes. This presentation builds on Part 8, which dealt with the drying of mangoes. It is recommended that you also view Part 8 to obtain this background information, even though you may not be drying mangoes themselves. As is the case in most drying activities, the key factors pertain to the temperature of the drying air, the velocity of the drying air, and the preparation of the material for drying. Tomatoes present some unique challenges that may not be encountered when drying other materials such as mangoes. Tomatoes are widely grown in many countries. As such, they are a popular suggestion whenever we ask a group of individuals what types of products they would like us to describe in our drying presentations. Each year, when the tomatoes mature, there is an overabundance in the marketplace, and prices go down significantly. As a result, tomatoes are frequently left in the fields where they literally rot on the vines. After a few weeks, tomatoes may once again be in short supply. This creates a need to import tomatoes at a higher cost without any benefit to the local growers. So here we have the local economy, and when we are exporting tomatoes, we have money coming back in to the local economy. However, if we have to import tomatoes to supply the local market, that means that money is leaving the local economy, which is something that we really do not want to have happen. From a personal perspective, tomatoes are not my favorite candidate for drying. This is due to the fact that they contain so much water, up to 95% by weight. And this means that you end up with only a small amount of dried product after removing such a large amount of water. We can start with 100 grams of tomatoes and end up with only 5 grams of solids, but to do so we have to remove 95 grams of water. Or if you prefer to deal in larger quantities, if we start with 100 kilograms of tomatoes and we remove 95 kilograms of water, we will only end up with 5 kilograms of solids. To me, tomatoes are more suited to thermal processing, where they can be processed into a variety of forms without requiring the large expenditures of energy and time to remove the water from them, as is the case with drying. Tomatoes can be canned as whole tomatoes, and here we see a can of whole tomatoes with the can open, and then we will pour the tomatoes out, and you can see how these whole Roma tomatoes have retained their shape. The tomatoes can also be canned as diced tomatoes, chopped tomatoes, and seasoned tomatoes in various forms. They can be processed into tomato sauce, which is a very liquidy material, but again it requires thermal processing. We can also produce tomato paste, which is much thicker, as you can see in the photograph here. Tomatoes can also be processed into tomato ketchup and other products, including things like tomato soup. The first problem, however, with my thought process is that there is often a lack of the necessary energy and canning facilities to thermally process tomatoes by canning. So we don't have energy present, which is a really big barrier to thermal processing. Another problem is the need to have an affordable supply of cans nearby, in addition to other infrastructure requirements, and this can be very expensive. Special liners are often required for products such as diced tomatoes, as shown in this photograph, where I have partially removed some of the diced tomatoes from this can, and you can see the white plasticized liner to prevent the acidified tomatoes from reacting with the metal can. This basically leaves drying as one of the few alternatives. Before we begin our discussion of drying tomatoes in a forced air dryer, we should look at how tomatoes are sun-dried, since this is a very popular form of dried tomatoes. Unfortunately, due to copyright rules, I am not able to reproduce any photographs of sun-drying operations from the internet. However, you may wish to take a look at some of the websites which show this. For sun-drying, Roma tomatoes are used because of their lower moisture content and higher solids content compared to the larger tomato varieties. The Roma tomatoes are thoroughly washed before being sliced in half. These tomato halves will ultimately be placed in large, shallow, flat trays to be set out in the hot sun to dry. The locations for sun drying must be hot, dry, and sunny, with a breeze if possible. Unfortunately, it takes about 1 week, that is 7 or even 8 days, to dry the tomatoes to the desired final moisture content of around 10% by weight moisture or less. As you can appreciate, the moist tomatoes can easily spoil during this time. To prevent spoilage, the tomatoes are treated prior to being placed out in the sun to dry. This pre-treatment may involve exposure to sulfur dioxide gas to create a preservative effect. In other cases, a solution of sodium metabisulfite may be used. Sulfur dioxide reacts with water to form a weak acid which aids in preservation. Here is the chemical reaction for the process, where we have sulfur dioxide, SO2, and water, H2O, reacting together to form sulfurous acid, H2SO3. Such treatment acts as a preservative, as already stated. It preserves color and acts as an agent against insect infestation. It is not really important to understand the chemistry involved here. The important thing to note is that some form of preservative is required when sun-drying tomatoes. We will direct our attention to using forced air dryers in this presentation. Now we can take a look at the drying mechanism, but we will not go into the specific drying mechanism for moisture removal in great detail here. However, the actual rate of moisture removal will be most rapid at the start of the run when there is a saturated surface. That means that we are working within the constant rate drying period, and that has been explained in previous presentations. The rate of drying will slow during the falling rate drying period as diffusion from the center of the material becomes more important. Do not be fooled by the slow rate at which water is being removed in the later stages of the drying process. This is a significant part of the process, and you need to carry it through to completion. You may remember that moisture is lost from the surface of the material. So here we have a rectangle representing the material with the center line shown as the dashed blue line across the middle. Moisture is then removed from the surface as indicated by the large blue arrows. In order to be removed from the material, moisture must travel from the interior to the surface by the process of diffusion, and that is shown by these smaller arrows from the center line to the surface. Tomatoes do not have a uniform composition as we experience with things like mangoes. Tomatoes may be unique in this respect. In addition to their fleshy portion, tomatoes have a somewhat liquid region called the placenta, which houses their seeds. Since the placenta has such a high water content, some processors remove it prior to drying and simply dry the fleshy portion of the tomato. Removing the placenta may reduce the time for drying, but it can also reduce the overall yield and may possibly lower the nutritional value of the dried material. For our purposes, we will leave the tomato intact and not remove the placenta. So let's take a look at the material preparation. In most cases, we prepare materials such as mangoes for drying by cutting them into thin slices, which are usually about 5 to 6 millimeters thick, or 0.5 to 0.6 centimeters thick. This will not be the case with tomatoes, however. It is recommended that you use only Roma or plum tomatoes, as I have already mentioned. Large, juicy tomatoes have elevated moisture levels and do not lend themselves to drying all that well. Even Roma tomatoes can have high water contents, so try to get lower moisture ones. Cutting these more moist tomatoes into slices is a messy and wasteful process due to losses, and in the case of this tomato slice, the placenta may actually fall out of the tomato during the drying process. After washing, Roma tomatoes should be cut in half lengthwise. Each of these halves should then be cut lengthwise into 4 wedges. That will give you 8 wedges per tomato. The wedges can then be placed in the dryer with the skin portion resting on the drying rack. That will have the wedges pointing upwards as shown in this photograph. This will support the contents of the tomato and prevent them from falling out during the drying process. Here we have a drying curve for tomato wedges at 50 degrees Celsius with an air velocity of 0.5 meters per second. In the beginning, the moisture content of these Roma tomatoes was 93.8% by weight, which translates into a dry basis moisture of 15.13 grams of water for every gram of dry solids that you have present. So looking at this curve, we see that the moisture content is starting out at 15.13 grams of water per gram of dry solids and is falling in a linear manner during the constant rate drying period, and that is shown by this dashed red line. The time for that constant rate drying period is approximately 2.5 hours from the start of the drying run. After this, we enter into the falling rate drying period, where diffusion of moisture from the interior portions of the tomato wedges becomes the dominant mechanism in the drying process. After approximately 18 hours, we reach 10% moisture on a wet basis, which is equivalent to 0.11 grams of water per gram of dry solids. So basically what we have to do here is remove 15 grams of water per gram of dry solids, or 15 kilograms of water per kilogram of dry solids. So as you can tell, there is an awful lot of moisture being removed to get the final dried material. After drying, the tomato wedges will look something like this, and you can see that there is considerable shrinkage that has occurred during drying. As with most materials, it is best to dry tomato wedges in a range of 50 degrees Celsius to 55 degrees Celsius. Beyond this, there is a risk of thermal damage, and case hardening may also be a problem. A sufficient air velocity is required to sweep away the stagnant boundary layer from the surface of the tomato wedges. 0.5 meters per second air velocity has been found to be quite suitable for this purpose. If you are unable to measure the actual air velocity, you should be able to feel a reasonable airflow in your dryer with your hand. Basically, the same rules apply for conducting the drying runs with tomato wedges as applied for mango slices and most other materials. As the run progresses, you need to check the material at regular intervals to be sure that there are no problems. If there is uneven drying, you may need to rotate the drying racks or change their position in the dryer. Tomato wedges will take about 18 hours or even more to dry, and we saw that in the drying curve a few slides ago. Do not try to rush the process. You need to remember that drying is a kinetic process. That means it's dependent upon time, and diffusion is something that you really cannot hurry along by simply trying to do things like raise the temperature to an excessively high level. When you feel that the material is fully dry, and we'll discuss that in the section on testing for doneness, which follows this one, you should remove the trays from the dryer. Allow the product to cool before packing it into containers or bags or boxes or other suitable packaging material. You should cool the product in a room that is not too humid in order to avoid the uptake of moisture during cooling. Here we see a dried tomato wedge which is still warm, and if you bring that into contact with moist air, it will actually draw moisture from the air as it cools down, and that will then essentially add to the moisture content of the dried tomato wedge, which is something that you do not want to do. You also need to remember that sanitation is an important consideration, as always. The cooled product can then be packaged into airtight, moisture-proof containers with a good seal. These containers can then be stored in a cool, dry area out of sunlight. You do not want product to be exposed to sunlight, which can actually damage the quality of the product. When it comes time to test for doneness, usually the final product will feel dry to the touch and have a leathery texture. The dried tomato slices or wedges will be somewhat stiff but pliable and will bend without cracking. If the final material is too dry, it will become brittle and crack when bent. And you do not want to over-dry the product because this will reduce your yield and it may impact the performance of the final product when it is put into use. Experience is a definite asset in being able to assess the end point of a drying process. You should document all run times and conditions to assist you with later runs, and this will also help you to determine the time that it takes to reach the end point in a drying run. Under-drying can result in spoilage due to mold growth, etc. during storage. So in summary, the following conditions are recommended for the drying of tomatoes in a forced air dryer. The shape of the tomatoes should be in wedges, and I would recommend that you cut your Roma tomatoes lengthwise into 8 wedges per tomato. The air temperature should be approximately 55 degrees Celsius, and the velocity of the air should be around 0.5 meters per second. You should resist the temptation to use temperatures of 60 degrees Celsius or higher to avoid problems with case hardening and the potential reduction of nutrition and quality attributes. You should also remember that drying involves many factors, including sanitation and product handling. Detailed records should be kept of all drying runs, and this is a very important thing to remember. Thank you very much.